Let's start with a new chapter called Determinants. So before getting into the definition, in the previous chapter, we have studied about the matrices, right? So in that, we have seen a concept in which we need to convert the system of algebraic equations in the form of matrices. So the equations like a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. These are the two equations which can be expressed in the form of matrices like a1, b1, a2, b2, which is a 2 cross 2 matrix, into the variable elements that are x and y is equal to the constants. Those are c1 and c2. Now, this system of equations has a unique solution or not. How can we check that? This can be determined by the number that is a1 b2 minus b2 minus b1 a2. So this number which determines the uniqueness of solution is called the determinant, which is denoted as det A, or we can also write it as det A. Now let's see the definition. To every square matrix A, it's a square matrix of order n, that is n cross n, we can associate a number called determinant of a square matrix A. So basically, determinant exists only for the square matrices, and for each and every square matrix, there is a determinant, which is a number which represents the whole matrix. Okay, and it is denoted by det of A. It is read as det of A, not modulus of A. Okay. Now let's see few examples. And example, if a matrix A, that is A, B, C, D, if this is a square matrix of order 2 cross 2, then the determinant of this matrix is represented as det of A, that is det of A, B, C, D. This can also be written as det of A. Now let's see how do we find the determinant for 2 cross 2 matrices or 3 cross 3 matrices.